So hello everyone, welcome back to the channel. Today we are going to solve the problem even swap. So you are given an array A and you need to generate an array B. You are allowed to apply only one type of operation any number of times. In one operation, you can swap AI and AI plus 1 if AI plus AI plus 1 is even. Okay. Array B should be generated after applying the above operation. Number of times on array A and array B should be lexicographically greatest, largest after applying the above operation. So let's understand the question. So what we want this condition to be followed that we need to swap when sum of a and ai plus 1 is even. What is ai and ai plus 1? Consecutive elements only. Okay, so we can say when the sum of, let's say I have element ai and ai plus 1, when their sum is even, I want to swap. Okay, now tell me one thing, when the sum can be even, when the two numbers are even. Okay, and the two numbers are odd. Yes. Okay, when the numbers are even odd, then sum cannot be even. It will be equal to odd only, obviously. Hai na? So we want this. If two numbers are even, if two numbers are odd, then only we can swap. So just question boils down that we need to find two even, two consecutive in, two consecutive odds. Okay. So now let us consider an example test case. We are given 1, 3, 4, 2, 5. So let's write even and odd, which is even, which is odd. This is odd, this is odd, this is even, and this is odd. So I know these two are odd, so I can swap. Now tell me one thing, is swapping them worth it? That means, let's say I want to swap this 1, 3. This will become 3 even. So obviously it will work. Why? Because if I am making the greater number ahead, so the number form will be larger. For example, I have 1, 3, 2, and another I have 3, 1, 2, which is greater. Obviously this. Why? Because I have greater number ahead. 3 is greater ahead. 1 is smaller. So obviously I want the greater numbers to come ahead. So that is the thing that we have to understand. We need to swap only when the AI is greater than, is less than AI plus 1. Why? Because previous number is greater and current number is smaller. So we need to make this ahead number to come before so that number form is greater. Okay. So let's say 1, 3, so I have swapped 3 and 1. Now, this number is 4 to 5. Now, can this 1 and 4 be swapped? No, because 1 is odd, 1 is even. Okay. Now, can this 4 and 2 be swapped? Yes, they can be swapped. So if I swap this, this will become 3, 1, 2, 4, 5. So will it be worth? No, obviously. Why? Because I have decreased the number. Why? Because this was 3, 1, 4 to 5. This is 3, 1, 2, 4. I want to make greater numbers ahead. Okay. So that's why this configuration will be wrong. Okay. Now come to 2 and 5. Obviously, they can not be swapped. So this is the largest number that we can form. And this is the answer. Okay. Now let's understand some observation that we can get from the question. Okay. Now let us take an example. We are given 2, 4, and 6. Okay. Now this is even, this is even, this is even. So obviously, what I want that this 6 should come ahead. Now this 4 should come before and 2 will come here. Okay. Now, now I can't swap 2 and 6. I cannot swap 2 and 6. So this is not possible. No, this is possible. Why? Because if I swap 2 and 4, this will become 4 too. Okay. So if I rub this from here, let's say if I have 4 and 2 and 4, so this become 4 too. Obviously, I want even. So I want this term to swap. Now this will become 6. Now, if I take this 2 and 6, they are even. So I can swap. So coming 6 before will be better. Okay. So 4, 6, 2. Okay. Now can I swap more? Yes. I can swap these two. If I swap these two are even, so I can say these two are even, this will become 6, 4, and this will become 2. Now, what is observation? Observation is that this number, which is smaller, can be converted into the increased number. How? Because all of them are even consecutively. All of them are even consecutively. So I can directly sort them in decreasing order and can get the answer. This is so why I'm doing this, because I am swapping between them. 2 and 4 will swap, 4 and 6 will swap, 6 will come ahead, 4 will come back, and they will swap between themselves and can form the greatest number. Okay. But if I have the, let's say I have any 1, 2, 3, 4, 5. So if I have no condition like this, that we have to swap when sum is even. So greatest number will be directly sorting it in decreasing order. Okay. But what I have condition that I have to swap only when E is consecutive or odd is consecutive. Okay. So I will say that whenever I find a group of numbers which are only even, or when I find a group which have odd, so directly I will sort them in decreasing order. In decreasing order, that means 6, 4, 2. Let's say I have 1, 2, 1, 3, 5. So I will sort them in decreasing order 5, 3, 1. Obviously, this will be greater than 1, 3, 5. So that the approach that we have to use. So we don't have to sort, we just have to, we don't have to swap, we just have to sort the consecutive numbers which follow the given condition that the consecutive elements are even and the consecutive elements are odd. Okay, so let's say I have these number 1 odd, 5 odd, 9 odd, 2 even, 6 even, 4 even, 7 odd, 2 even. Now, which is the group? This is the group which is matching odd, odd, odd. So I can swap between them. So instead of swapping, just sort them. This will become 9, 5, 1. Okay. Now this is a group 2, 6, 4. These are even, even, even. I can't take this odd. Why? Because this will not follow the condition. Their sum will not be even. Na? That is the thing. So we will sort them in decreasing order. This will become 6, 4, 2. This is only one group that can be formed because I can't take this. I can't take this. So I will say this will become 7 and this will remain 2 as it is. So the observation that I'm again repeating that we want to make the bigger number to come ahead. That is our main thing. Now we want to make this greater number to come ahead. Now this number will come ahead when we sort in decreasing order. But I can't make this whole array in decreasing order. We can only make this in decreasing order when all the consecutive elements are even or all the consecutive elements are odd. Because this is the condition, we can only swap when the two elements are odd or when the two elements are even only, and they will swap between themselves to form the greatest number. That is a decreasing number. That's why we are sorting in decreasing order. Okay. So how can we approach, like how I can take the groups and sort them? Okay. So what I do, I will maintain a previous pointer here and my I pointer is here. Now is 1n. Let's say I am I. Now if array of I and array of I minus 1, here is array of I, here is array of I minus 1. Are they both odd or are they both even? Yes, they both are odd. Okay, fine. Let's go ahead. Let's go ahead. Don't do anything. Let's go ahead. So I will say I pointer. Let's go ahead. So this pointer will come here. Now is AI and AI minus 1. Are they both odd? Yes, yes. So let's go ahead. Again, go ahead. Okay. So this I will come here. Now, are they both odd? Now, no, this is even, this is odd. Okay. So the previous group that we have formed, starting from the previous pointer, is a group which can be sorted. So what I will do, I will sort this group. I will sort this group. This will become 951. Okay. And shift this previous pointer here to I. Okay. Now, next time I will go again ahead. Okay. Now, next time I will go again ahead and check if they both are even. Yes, they both are even or they both are odd. They both are even. Okay. So I pointer shift ahead. Okay. So again, if they both are even, yes, they both are even. Okay. So I pointer, let's shift ahead. So I pointer will come here again. Now I pointer will say this is odd. This is odd. This is even. This is not following the condition. That means whatever was the previous group, let's sort this in decreasing order. This will become 6, 4, and 2. Okay. And the previous pointer will again come here. Now, previous pointer will again come here. Now, let's say again, I again shift the I pointer. So I pointer will come here. Now I pointer will say, are they both matching? No, obviously not. This is odd, this is even. So let's sort. This was a single element. So this single element will remain as it is. Now I point, so previous pointer will again come here. Okay. Now previous pointer will again come here. Now I pointer will again go. So the I pointer will be come outside the loop. So at the end, we will sort the whatever the group left, we'll sort it outside the loop as well. So this is the answer, largest number that we got. So what was the main hint about this question? We don't need to swap between consecutive elements again and again. We will take 2, we will take 2, we will take 4. So it will become 4, 2, this will become 2, 6, this will become 6, 2. Now this will become 6, 4, 2. So instead of swapping between them, if I can swap between them, let's say they are even, they are even. If I swap between them, so just sort them in decreasing order, and this is our answer. Okay, so this is the hint of this question. So let's code up this approach. So what we do initially we have a previous pointer which is equals to 0, which will keep track of the previous element. Now we will start a loop from the 1th element, and what we do, if both are even, that is if the remainder of both of them is equal, that is element current and previous. As I said, if both are odd or both are even, then I can swap. Okay, I will not swap. I will just say, okay, continue, go. I pointer should go ahead. Okay. Now, if they are not matching, that means this the previous group. That means the previous group that was formed. Previous group was what? Was a group that can be sorted, in decreasing order. Okay. So why decreasing order? So that 7, 6, 2 like this come here, and this will make the number more bigger rather than 2, 6, 7, obviously. So what we do is sort the a dot begin starting from the previous pointer. So and for getting the previous pointer, we will say that how can we do this? Let me tell you. Like let's say a dot begin means Let's say this is my array, and here a dot begin lies here. And let's say my previous is 2. So 0, 1, 2. So a dot begin plus previous will come here. So obviously I will take the group, whatever group I have to take. Now, another thing that we have to understand, that whenever a dot end, what a dot end indicates. Like let's say I have an array. This is array. This is a dot begin. A dot end never lies here. A dot end lies outside the loop. That means a dot end lies here. Okay. After the last element, let's say 0, 1, 2, 3, 4. So it will lie at fifth index. You can say a dot end lies after the last index. Okay. Now, another thing that we have to understand, let's say I have a dot, let's say my previous is 1. That means my group starts from here. And let's say my group ends here. Okay. So this is a previous pointer. So how I can access the first index? This is a dot begin plus previous. Now the first index we have got. Now how can we consider this last element? Whenever we do the sorting, what is the sorting function, inbuilt function? It will take two parameter a dot begin plus a dot end. Okay. Now a dot begin is the first index. So we have taken first index a dot begin plus previous. Okay. Now this is the first index that we have taken. Now a dot end is outside the loop. So for considering this index as the last index, we have to take, let's say my I is here. So we have to take a dot begin plus I. Okay. This is a basic condition that we should know. Like what do we apply? Let's say a dot begin plus previous, comma, a dot begin plus I. Why plus I? Because let's say I am again repeating, my previous is here and my I is here. I want only this index to be possible. So sorting will take the first index. First index is a dot begin plus previous, as I've said. And the second index should be one ahead. We will say a dot begin plus I. Okay. Now, since we want to sort in decreasing order, so we will add extra parameter greater int. This will sort the given array in decreasing order. If we do not add this, this will sort in increasing order. But I want in decreasing order, that's why I add this parameter. So what do we do? Whatever group we have found, I will sort this in decreasing order from a dot begin plus a dot previous plus a comma a dot begin plus I. That is the element after the last index. Okay. Now, since we want them into in decreasing order, so we'll add greater in here so that it can be added in. It can be sorted in decreasing. Okay. Now, what we do, as I said, whenever we have sorted the previous part, we will shift the previous pointer to I. That is, this is a new group that is starting. New group starting here. Okay. Now, at the end, because if the last pointer, previous pointer left, we will sort it again. Now we can end here. Why? Because my last index, we can end a plus I also here, because a dot begin, let's say here. Previous is here. So we will add a dot begin plus previous. So this is shifted here. Now a dot end is here. So for considering this group, we should add this index. Okay, this pointer a dot end. Okay, so I will add this here. Now add, then what we'll do? We will return a as it is. So let's compile it in the code. Obviously, I have to add greater int here. I forgot adding. Let's compare in the code again. Yes, so let's commit the code. So yes, it is totally working fine. Now one question is how time complexity is bigger of n log n. So this is because, let's say, so we can say that this is big of n loop here, and inside we are sorting. This will become big of n log n. So this will in total will become big of n square log n. No, not actually. Why? Because this will become big of n square log n when we are traversing the array, and for every index we are sorting whole array. Then that should become big of n log n. But we are not sorting whole array. For every index, let's say I have taken this group. Now I'm taking this group and then I'm sorting this. I am starting from this index, then I'm sorting this here, then I'm sorting this here. So this is not actually big of n square log n. Let's say I have three elements. So this is 3 log 3. This is 4 log 4. Not actually big of n log n, big of n into big of n log n. N log n when the whole array is taken. We are not taking the whole array. Then that means we are traversing n loop, and with that we are adding the big of n log n actually. This will approximately will become big of n log n. I hope you get the time complexity I wanted to say. All about code. So the just hint was here. If AI plus 1 is even, odd or even, we have to take. Secondly, for taking consecutive groups, taking the group of elements, let's say I have 2, 4, and 6. So instead of taking them, just sort them in decreasing order because they will swap them itself. I just want the answer. I don't want to show the swapping. So that's all about this intuition about this code. So this was all about code. Thank you and have a nice day.